really excited to be able to do that. And also, big thank you to Dryden Youth Opportunity Fund. They've been an amazing sponsor of this series for several years, and you may or may not know, but they do so many things in the community for all of you, for youth in this area. So it's awesome we have them once again supporting us this year. So a couple of things to take care of before we get rolling today, folks. Just make sure your cell phones are powered down or vibrating or whatever. Just keep them off or in sleep mode, whatever you kids do. And please refrain from using those, of course, during the presentation. If for any reason we had to leave, there are 4 exits, 2 back there. You guys probably came in that way. And there's 2 more back there as well, but hopefully we can stay here the whole hour. And the things we want to talk about before we get rolling today. So students, you may or may not agree with me when I say this, but you are very, very lucky to live in Dryden. You are very fortunate to live here and be here and that. You guys are all shaking your heads. Yes, you're so fortunate, right? Mm-hmm. Yes. The reason for this, guys, you all heard of the cradle of civilization, right? Global students, cradle of civilization. Very good, thank you. One person knows. I'll tell the global people. Yeah, Dryden is the cradle of opportunity, the cradle of higher learning. Guys, think about it. We've got Cornell down the road, SUNY College to the left of us. We've got TC3 right here in town. Just up the road, we've got SUNY Cortland. There aren't many places around where you can live in a small town and have all these amazing institutions right in our backyard. So don't lose sight of that. It's really important that you know that. Really important to take advantage of that. Whether it be directly involved in those institutions or other activities or things that they just have for you to be involved in. And along with that, many of the people that work in those places come here to give these presentations. And often we get like spin-off companies and businesses associated with those institutions, and they do a lot for our school as well. So Drydenites, we're very fortunate to live here. So that's wonderful stuff. So let's get rolling today. So to introduce our presenters, we have Mr. Jackson Crocker.
Theresa received her BS in biochemistry and biophysics from the State University of New York at Plattsburgh. She then received her PhD from Albany Medical College in physiology and cell biology and completed a postdoctoral fellowship at the University of Virginia School of Medicine. After her postdoc, she moved to Ithaca and took a position as a research scientist at Agave Biosystems. While at Agave, she was the principal investigator for projects funded through the Department of Defense, DoD, including the development of a cell-based sensor to detect chemical and biological contaminants in drinking water. Theresa is now a professor at SUNY Cortland, where she teaches anatomy and physiology, serves as the pre-medical advisor for the college, and continues her Department of Defense support research. Theresa feels very fortunate to call Dryden home with her loving and two amazing children, and supportive and talented husband. He wrote that. Brittany Apuzza is currently a senior at SUNY College. She attended Herrick's High School in Long Island and was a cheerleader and played soccer. She is currently a biology major with a chemistry minor and is on the pre-med track. Brittany does research with Dr. Theresa Curtis on neuroblasts and arsenic, as well as marine biology research with Dr. Laura Ehrman. She is the vice president of SUNY Cortland's pre-med club and is the president of SUNY Cortland's chapter of Tri Beta, the Biology Honor Society, and plays intramural soccer. Brittany plans on attending medical school in the fall of 2020 and hopes to become a reproductive endocrinologist and infertility specialist. Luykas van Alstyne graduated from Ichabod Crane High School in 2014, where he played soccer, basketball, and ran track. After high school, Luykas attended Hudson Valley Community College and graduated with an associate's degree in physical education. He transferred to SUNY Cortland as an exercise science major and changed his major to biomedical science after his first semester. Luykas is currently doing research with neuroblast cells in Dr. Curtis's lab. Please join me in welcoming Dr. Theresa Curtis, Brittany Apuzza, and Luykas van Alstyne.
Hi, everybody. Welcome. Thank you so much, Jackson, for the introduction. That was awesome. Thank you, everybody, for coming. I know I'm taking you away from your homework and your video games and your whatever high school kids do all night, I don't know, because Jackson has his door closed. Okay, so I'm here doing conversation with scientists. I didn't have much of a choice since I'm married to Mr. Crocker, but I did want to tell you what I'm doing because it's just right down the road, and I wanted to bring my students to tell you what it's like to be a science major at SUNY Cortland. So my basic outline today is here, but I'll talk about anything you guys want to talk about. So I'm going to talk about basically my career path and some of the basic lessons learned that might apply to you as you guys are young and starting out. I'm also going to talk about what I do all day, in case you care. And I'm going to pass it, and part of like what I do all day is I'm going to talk about my research and talk about pre-med advising and talk about my teaching. And then I'll pass it off to my students and they can talk about what it's like to be a college student at SUNY Cortland. So before we get to that, I forgot that I was there. Mr. Crocker made a really big mistake inviting me tonight without proofing my PowerPoint presentation. So he's never going to invite me back, so let's have some fun. Sorry, his parents like yelled at me with the picture. So that was Mr. Crocker's childhood. He was very So there'll be a few little surprises as we're going along. Yes. Okay, so my path. Okay, so in high school, I loved science. I loved all sciences, but interestingly, I did not like earth science. I had a great, really funny professor, and he was really intelligent, but I just didn't like earth science, which was good, because I narrowed down one science I didn't like. But I loved biology, I loved chemistry, I loved physics. Physics was a little bit it was okay. And I was really good in math. So I couldn't decide, so I found a major that was called biochemistry, biophysics at SUNY Plattsburgh. Perfect, 7 hours away. I grew up in Rochester, in the middle of the Adirondacks, really beautiful. I met Mr. Crocker there. Everything was great. When I was there, taking all these general science classes, I soon realized, I started narrowing down, that's what college is so good for, and that's what you guys all have to do when you're in college, is take advantage of things that you can do outside the classroom. So you can't just go to your classes and figure it out that way. You got to take advantage of these talks. What Mr. Crocker and Mrs. Taylor have done is great here. I know you guys are required to come to this, but it's really, really important that you're here, because maybe 5 of you will take home something from this talk, and maybe you won't, but it's really important to put yourself out there and get these opportunities. So when I was in college, I didn't do everything I could have, but I did some things, and I was really interested, I knew I was really interested in the human body. Anytime they were talking about anything with the human body, I was I have to do something with studying the human body, or I have to be a physician or something. And I didn't really know what I wanted to do, so one summer, instead of working I always used to work in a grocery store in the summer, and one summer I decided I have to get a job in a hospital to figure out if I want to be a physician or not. And so I got a job as a certified nurse's aide for a summer in a hospital, and it was the craziest job. I had the coolest stories, all these crazy things happened, but I realized that I did not want to be around patients. It was too crazy, seeing people die, and all the emotional part of it, I wasn't ready for it, and I knew that I didn't want to work with patients, and I just wanted to be in a lab, making the medical discoveries and coming up with the treatment. So I really wanted to do medical research. So that's what I figured out in college, which I was very lucky that I was able to figure that out, because then I went straight into a PhD program at Albany Med, and I loved Albany Med. I found it because it was the research building was connected to the hospital, so it was physicians and PhDs were all together doing, making medical discoveries. And so it was a really exciting place. There was people working on heart disease and diabetes and lung failure and just all this really cool stuff. And there's patients walking all around, patient samples, and doctors would rotate in different labs. They would do a research residency in different labs. So it was very medically oriented and I loved it. So I did that. What a PhD is, if you're wondering, like if you want to be a scientist, it's about a 5-year thing where you're in classes and you do research and they're basically training you how to be a scientist. They're training you how to do the experiments, how to write papers, how to go to meetings, like how to do all that stuff. So they train you to do that. Then I had to go, then you have to do a postdoc fellowship. So just like a doctor, you get like an MD, you have to like get trained to be a doctor. Then you do a residency, which is you're kind of working as a doctor, but you're still under supervision. The same thing happens in science. So they train you to be a scientist, but then you have to do this postdoc thing, which is you're kind of a little more independent. You're kind of trying yourself out as a scientist, but you still have a supervisor. And so I did that for 4 years. It was great. University of Virginia was awesome. Charlottesville was great. Travis approved living there, so I interviewed other places, but he's like, no, we can't live there, we can't live there. And he was okay with Charlottesville, so that was cool. So we went to Charlottesville. We bought our first house together, and once I was done with my postdoc, I was a real scientist. I was ready to get my first real job. And I was 31 years old. So it's a lot of schooling if you want to be a scientist. And things that I learned that I want to pass on to you guys is that you have to take advantage of anything outside the classroom because you have to figure out what you want to do. What do you want to go to college? Do you not want to go to college? What career do you want to do? And you're not going to figure it out just sitting in class and watching TV. You don't know how many people, I'm the pre-med advisor at SUNY Cortland, and I have so many pre-meds, not Brittany, that want to be doctors because of Grey's Anatomy. And I'm pretty confident that being a doctor is not like it is on Grey's Anatomy. I mean, it might be in some small places, but I'm pretty sure it's not. So you gotta get active outside of the classroom. You have to do internships. You have to shadow people. You have to go to talks and talk to people. You also have to seek mentors like along the way. So I had people, like your parents are helping you now, and you might have family friends that are helping you now, but as you leave high school and go on, you need to seek out adult mentors that are going to help you along the way and give you good advice and get a lot of advice. I had great mentors that helped me along the way and start building a professional network. You guys don't know it now, but look around the room, look at who you're sitting next to. That is your professional network. I know, scary. But seriously, someday, Ben Lee is he's gonna own a company that you're gonna want to work for, and you're gonna be like, oh man, I went to high school with Ben Lee, and there's your business contact, okay? So be nice to people, don't bully people, and you're building your professional network right now, okay? So be nice and stay socially connected. Okay, so I got my first job when I was 31 years old. When all my friends that I went to college with had like real houses and real furniture, I was literally had like a futon, and I was like with Mr. Crocker. And we were sleeping on a futon. I don't know. We didn't have any real furniture because it was like his first teaching job, my first job. So yeah, it's cool though, because I have a really awesome career, so it's worth all the schooling. So the first job I took was at Agave Biosystems. It's a small company. Do you guys know where Gateway Plaza is in downtown Ithaca? It's where like the clock tower is. It was actually in there. And we were in there with law offices and PT offices, and we were doing like Department of Defense research in there, which I'll get to in a minute. I was there for 6 years. It was awesome. It was all these like young people, engineers, microbiologists, cell biologists, geneticists, like all different people. And we were basically building biosensors for the Department of Defense to detect different things in the environment, like different biological and chemical like warfare agents is what we were working on. I loved it there, but it was a startup company, and startup companies are really exciting when you're young, and we had so many awesome ideas, and we were making a lot of But all the money that I got was all soft money, meaning that it was all grant money. So I would get a grant, and then I knew I had a job for 2 years. At the end of the 2 years, I didn't know if I had a job or not, because there was no like real revenue coming in. It was just grant money. And I started having kids. I started having Jackson and McKenna. And I started figuring out that I needed to have a more stable job. I couldn't have a job where like every year I didn't know if I was going to have a job or not. So that's what startup companies are really exciting places. They're really scary places, especially when you live in Ithaca or in Dryden, where there's not like a lot of companies. So if like that company folded, it wasn't like I could just go right down the street and get another job. So if I lived in Boston, I would have like risked it and been like, oh yeah, I can just get another job. But here I was getting concerned. So I started looking around for other jobs, and a professor job opened up at SUNY Cortland. They were looking for a physiologist, and I had a PhD in physiology. I'm like, okay, but I had really very minimal teaching experience. So it was scary. I applied. I puffed up my resume. I actually applied. I didn't apply to a tenure track position because I would have never gotten that because I didn't have enough teaching experience. So it was a visiting assistant professorship, which they're willing, it's just like a 1-year position, and they just need someone to fill in before they can do like a real search. And so I took that position, hoping that I could make it work and I could really show them that I could be a great teacher and a researcher, and I did, and I got the tenure track line. And so I've been there for 11 years. And I love it there. This is a picture of my Bowers Hall at SUNY Cortland, where all the sciences are. It's like the biology department's there, chemistry, physics, and geology. And that's a picture of my research lab. That's not Brittany and Luykas, but that's my students from a couple years ago. And that's my research lab. So, That's the worst of them. This is Mr. Crocker as a teenager. Who's heard the story that Mr. Crocker was... Who's heard the story that Mr. Crocker was a linebacker in high school? Who believes it now? Yeah! Who believed it when they saw him here? So Mr. Crocker used to be very muscular. No, he was literally a linebacker in high school. I'm not joking. He really was. So it was a small school, but he was really a linebacker. At least he had it. Oh, you guys, okay. So I'm at SUNY Cortland. Okay, what do I do all day? What does a professor do all day? It doesn't really matter where you are as a professor. Pretty much every professor has to teach. Why is this thing not working? You have to teach, you have to do research, and you have to do some sort of service, which is you have to do something for the college. It depends on what college you are, like what percent of those 3 things you're going to do. Like if you're at an institution that does more research and you're doing a lot more research with a little bit of teaching. If you're at a college that doesn't do as much research, then you're definitely doing like more teaching. SUNY Cortland, I love it because it's a pretty equal mix of, I would say my teaching and research is pretty equal and my service is a little more minimal. I don't spend as much time on that, but it is a nice even mix. So for this semester, this is like what I do. This is like my teaching obligation. So I'm currently teaching a class. It's called Human Physiology. It's to juniors and seniors. So Luykas is in my class right now. It's an elective course that bio students take, like if they want. So it's a lot of pre-meds, pre-dental, pre-PT students. And a typical like science course, you sit in the course usually like 3 times a week for 50 minutes. This is like the lecture part. And then you go to 1 3-hour lab like once a week. So I have 34 students in this class, and then I have the students split into 2 different lab sections. So half the students are in the morning lab and half the students in the afternoon lab. But over time, something's happened, and now I have a bunch more students in the afternoon lab because the college students don't want to wake up in the morning. So I have like 14 students in the morning lab and like 20 in the afternoon. they're not supposed to be in there. So this is like a typical, this is my teaching obligation. So it's at SUNY Cortland, you're required to do 9 contact hours. So that means, what does that mean? It means that I'm with students 9 hours a week. So that's my teaching load. And then I'm required to run office hours. So I have to have 5 office hours a week where I'm definitely in my office and I'm sitting there in case students have any questions. Sometimes I'm sitting there just answering my emails. Sometimes I have like 5 students in there. It's very cyclic depending on like if there's tests or whatever. And then I have like a department meeting. And then the rest of the time here, I'm doing my research. And I have 2 research students that are awesome. So they're somewhat independent. It just depends. Like Luykas just started. Brittany's been with me this is her 2nd semester, so she's a lot more independent. But sometimes they're in the lab by themselves. Sometimes I'm in the lab with them. During that time, I'm reading papers, writing grants, writing papers, trying to figure out what the next experiment is, analyzing data. So a lot of this time is research. And then a bunch of time also is spent towards my service, which I do at SUNY Cortland. You can pick any kind of service you want to do. Since I've started, I've been the pre-med advisor for the college. So if you're at SUNY Cortland, you're interested in going to medical school, dental school, or PA school, you would come to talk to me. And I would meet with you like once a semester or possibly more to make sure that you're meeting all the requirements to get into these schools. So that keeps me pretty busy. I try to get the students to come to my office hours for this, but it doesn't always work. And so I have a lot of students that are just coming like random times. And I'll talk a little bit more. Mr. Crocker wanted me to add some pre-med advising stuff at the end in case people were interested in that for a career. So I'll talk a little more about that. But what I wanted to talk about for a big part of the time is just like, what is my research? Like, what am I doing at SUNY Cortland? Because it's really cool because I work for the Department of Defense. So I thought you guys would be really interested in it. I started this research when I was at Agavi in downtown Ithaca. And I started this research, it was basically like a couple weeks after 9/11. And the Army, more specifically the United States Army Center for Environmental Health Research, was very concerned about our drinking water. Like after 9/11, after those attacks, they thought we have drinking water all around this country that is not safe from a terrorist attack. And I put a picture of New York City's drinking water just as an example. So New York City is way down here, and they have like a treatment facility right here. But New York City gets all of its water from basically above ground reservoirs, and all the water is piped to New York City through aqueducts or tunnels. And this is a picture of one of the reservoirs. They're beautiful. Some of them have a chain link fence around them, some of them don't have anything around them, and that's New York City's drinking water. And literally some crazy chemist, you can't trust the chemists, could synthesize some crazy compounds that we don't have a test for and put it in one of these reservoirs and kill a big part of New York City off. And that's what the Army was is super concerned about. So they were very concerned about this. So a little side note. In case you don't know, because I'm sure you guys don't work in a water treatment plant, how water treatment plants work, especially the big one here. I don't know how the Dragon one works. I'm sure they're probably testing the water like once a month. But in New York City, they're testing that water every single day, but they have specific analyte-specific tests. So they'll test the water for lead, they'll test the water for mercury, for like different pesticides, but they're all very specific to a certain compound. They have no test that can test some crazy chemical compound that a terrorist came up with. Okay, so we are not safe from that. So what I wanted to ask you guys what you think about. You guys are very smart because you have Mr. Crocker as a teacher. So some of you. This is the problem, okay? How do we solve it? How do we keep New York City's drinking water safe? What would be your solution to this? Come on, Patrick.
Show off your camera.
That's a good solution. Felipe, what's your idea? How would you ensure that someone didn't put some crazy chemical that we don't have a test for in our drinking water? How would you?
So all the water has to go down to that one facility in one.
Yeah, the facility, and it can test the water, but we don't have a test for something that we don't even know what the terrorists can come up with.
Okay.
So how would we know if that water is going to kill us or not?
Okay, so I assume you could. Yes.
I'm going to put Jackson on the spot. Jackson.
Looking for a spring to build a wall, but that's not going to work.
Build a wall about, okay, that's bad. Okay, what do you guys, does anyone actually have an idea? Yeah. No, that's,
Yeah, you. Maybe if there was a way to make a test that just tested for any abnormality in the water, like generally, and then you could do more specific tests afterwards.
yeah, there is systems that exist that can test for any chemical in the water. It's super expensive and not practical, but the technology is getting better, and that will be online in 5 years, maybe 10 years. But we need something now. Actually, the Army is already active. So this was back in 2001. So something is in New York City's drinking water right now that will test, get it.
Is there like a cell or organ in there that like it's
That's
dying?
cheating.
It is cheating.
Okay, what would you guys do if Jackson was a crazy dictator that you guys all wanted to kill him because he was a really bad ruler, and you guys were like poisoning his water and his food? How would Jackson like? Yeah, taste tester. You would make your servant drink your water and taste your food before you would eat. Yeah. Okay, so you would have another organism taste the water before you tasted the water. Awesome. Okay, we can't do that. That's frowned upon. Can't trust New York City's drinking water. That's not good. But we can use animals. So have you guys ever heard of Sentinel species? Have you guys ever heard of the canary in the coal mine? Yeah, so way back when, we have sensors now that are better, but before we had sensors, coal miners would go into the coal mine and they would bring a canary, and the canary would be chirping away, singing, whatever, and then the minute the canary stopped singing, the coal miners would know they'd have to drop everything and run out of the mine, because mining can liberate carbon monoxide, which is colorless and odorless and can kill you very quickly. It will kill the canary first because the canary is smaller than a human, and so when the canary stops chirping, you have to run out of the mine or you're going to die. So it's called a sentinel species, using another species to indicate toxicity. So the Army that I'm working for actually came up with a system in the early 2000s. It's an actual fish biomonitor system. This is no joke, it's so cool. They use bluegill fish, and they have them in these little chambers, and they literally pass drinking water past these little swimming chambers, and they have an electrode above the fish, and they're measuring the fish, how much it ventilates, does it cough, how it's moving, and they've shown that these fish are super sensitive to all kinds of different chemicals. Fish will change their ventilation rate, and they'll start coughing to try to get the chemicals out of their gills, and it's super, super sensitive to every class of chemicals. They literally have this system in line with New York City's drinking water now, and they have it in line with Washington, D.C.'s and like the Pentagon and all that. They have this fish biomonitor system. Exactly for this reason, for terrorist attack on something that we don't know what the compound could be, but if the fish start getting perturbed, then we should stop the water from going to people, kind of idea. So this is a real product now that's actually being used. The problem with this thing is that you need biologists to man it. The fish get really stressed out. They can only be in there for a couple hours. You have to like rotate them. It's a very expensive system. The infrastructure is really huge. So sure, it's awesome for New York City awesome for Washington DC, not really gonna work for drive-in, so they can like off the whole town with drive-in if they wanted to. Luckily, they don't, use it. So this isn't practical for everything, and it's certainly not practical for anything. Like the Army wanted something kind of like field portable too. The Army wanted something to protect us in the United States, but they wanted something that like armed services could go around the world and take, and take with them to make sure that like a well they find is safe to drink and stuff like that. So the Army came up, this is what the Army does, this is what Department of Defense does. They take your taxpayer money. Department of Defense takes a lot of your money. Luckily, a lot of it goes to research. And what the Army will do with this research money is they'll send out these solicitations. And you can actually apply to these if you need a PhD, you need to have a lab, you can say that your garage is your lab. And you can read these solicitations, and if you have an awesome idea, you can write a grant and apply for them. And say, this is my awesome idea, give me $1 million. Try it out. And so this is how the Department of Defense works. It's pretty cool because they have this problem and they don't know how to solve it, and they ask all the scientists in the United States to come up with an idea. And so this was their problem. They wanted something to detect all chemicals in water. We don't care what the mode of action is, we want to detect all of them. We want the sensitivity to be relevant to humans, so we want to be able to detect under the human lethal concentration, obviously. But we want to detect, we don't want a lot of false positives either. So we want it to be like a real dose that actually hurts someone. So the military has these, they're called military exposure guidelines. I don't really know how they got them. Where they say if you drink like 2 liters of water a day, if the chemical's at this concentration, it won't hurt you. You can do that for like 2 weeks. So they have those guidelines. They wanted something to respond like really quickly, and they wanted it to be really field portable. So obviously the fish system's not going to work. You can't be carting a whole fish around with you everywhere you're going. It'd be kind of cool, but you can't do it. So I looked at this initially and I said, I don't have any ideas. This is crazy. They're asking for too much. And the owner, I was at a Gavi at the time, and the owner of my company's like, oh, you're a cell biologist. You can come up with a solution to this. You like do it. He was like pushing me to write a grant. I'm like, I don't have an idea. And so he's like pushing me. And so I finally did come up with an idea after him pushing me for weeks, where I decided that I could use isolated cells from organisms. So you can literally from a company, you can buy cells. I can buy human neurons, I can buy human skin, I can buy kidney, I can buy stomach cells, I can buy any cell from any part of your body. This is literally $400 for go buy all of them. And I can grow them on a little chip. I actually brought the chips with me. And you can actually get cells from other organisms too. The stuff that they have for humans